This video is going to supplement our electromagnetic spectrum PowerPoint. Be sure to take a really good look through this because this is really the application of it. So inside the PowerPoint, you were introduced to these forms of radiation, where radio being long wave radio, short wave, FM, AM, those are the types of radiation that have really long waves, could be as large as buildings or football fields. So the wavelength is quite large, and it's not very frequent because to go from crest to crest, it takes quite a, well, it's not really that long, but relatively quite a long time to have one full wave in comparison to the kinds of electromagnetic radiation that are further down the spectrum, like X-rays or gamma rays, where you're going to have quite a few waves, crest to crest or trough to trough, within 1 second interval. So the word energy and frequency are often interchangeable. Let's check it out. Let's compare microwave radiation and ultraviolet radiation. So if we think about frequency, which has the lower frequency, microwave or ultraviolet? And if we come back to our chart, and whether you're having radio on this side or radio on this side, you really have to sort of ground yourself with whatever tool that you're using here. So lower frequency, I've got microwave, I've got ultraviolet. Where is the frequency the lowest? Well, this is a region of highest frequency, so down here must be a region of lower frequency. And we know this with infrared. This is your channel changer. So this is not harmful radiation to our bodies, whereas something like ultraviolet, we're wearing sunscreen to protect ourselves, to protect our skin, our tissues from that damaging radiation based on its frequency. So lower frequency, microwave. Shorter wavelength, microwave or ultra. So microwave, we're in that region of really long wavelengths, where ultraviolet is definitely starting to get to be shorter wavelength, higher frequency. So this would be a UV. And you'll notice that the wavelength and frequency relationship is inverse. When one is big, the other is small. So of microwave or ultraviolet, which has the highest energy, again, energy is sort of synonymous with frequency, so which is the highest frequency, and we're high frequency over at the gamma ray end. So ultraviolet will be the highest energy of microwave or ultraviolet. So the one region on the spectrum that's a little bit strange is the visible light, because there's light within that one type of radiation. These are all forms of light, but in terms of visible light, we can kind of categorize that, cut it down into this Roy G. Biv. So red, orange, yellow, green, blue, indigo, violet. So in terms of our question here, we're going to compare orange and blue light. So we've got orange here, blue here. Red falls closest to the ultraviolet on the spectrum, and violet obviously falls closest to the ultraviolet on the spectrum. So when we write it out, this is actually perfectly in order. The same as how I have the spectrum written here. So for lower frequency means higher wavelength. The red has the highest wavelength, and so you would get less of the waves. So the one that's closest to infrared and red is orange. The one with the shortest wavelength, so this again would be nice and long here, but over on this side going into ultraviolet, it will become shorter. So the blue wavelength is closest to the ultraviolet. So we would say blue visible light, it has shorter wavelengths, which also means then it has highest energy.